right? So let us see what is tangent journal. So we have seen all these data production techniques, right? So the disk level production, we have seen the RAID. So within RAID 1 and RAID 5. Okay. And then AMP level production is called as fallback cluster, where a group of AMPs are combined as a cluster, and it use the records as primary rows and fallback rows, and you will get the data even though one AMP is failed in the cluster. Okay. With the combination of RAID and fallback, it is very much efficient way of fault tolerance. And in case a node failure happen, then the technique which is used to get the data production is called as clique. Okay. The group of nodes which share a common pool of memory is called as a clique, and if one node fails, the virtual processors will be migrated to other active nodes and still continue to access. Okay. And there is one more technique called as hot standby node, where you won't feel any performance glitch also even though one node failed, because one node is sitting idle. Whenever a node fail in this clique, then only this node will active and get the virtual processors of the failed node. Okay, so there is no performance degradation in this method of hot standby node. And we have seen locks. When objects are accessed by different users simultaneously, you have to have a mechanism where you can control the accesses of the users on the objects. Okay, that mechanism is called as locks, and we have access, read, write, and exclusive locks, and we can have 3 levels of locks on the objects, and these are the default locks applied. And this is the priority of the locking mechanism. Okay, once we already obtain access, how it would wait for. And this is the priorities, and how they would wait in a queue, parallel queue and sequential queue. Okay, so this is object level protection. Okay, after this, we have one more protection called transaction level protection. What is a transaction? Transaction is the group of statements which has to be executed as a single batch, right? Means single run. Yesterday we have taken example of fund transfer, similar way. Okay. If we are doing a fund transfer transaction, it involves 2 SQLs. One is to debit the amount and one is the credit the amount. If both the actions are performed well, then only we can say the transaction is success. Otherwise, even a single statement failed, the transaction is failed, and the object status should be as how it was before actually we started this transaction. Otherwise, the data integrity will be lost. Yeah, so both the tables should be rolled back to before actually you started the transaction. Okay. So to enable that, Teradata has to do a journal. What is the journal? Journal means noting down the transactions or noting down the actions. The journal means noting down the actions. So what it notes, whenever you are trying to do a transaction or whenever you try to change any value in the object, it will take a journal of the before image. It means before the transaction, it will take the impacted rows as a before image. That is a simple backup you can think of. It will take, let's suppose I have 100 rows in the employee table and I'm trying to update some 10 rows because of some condition. So all those 10 rows which will be impacted with this update statement are taken as a before image. Okay. And it will try to execute all the statements. If all the statements in the transaction are executed successfully, then it will discard the before image. It won't use it. But in case if the transaction failed, that means any of the SQL in the transaction failed, then it will apply the before image again on the tables so that it will get the status back of the tables how they were before we started the transaction. Okay, so it is all automatic. You no need to do anything. It is the RDBMS maintenance. Whenever you try to do any operation, it will try to take a before image of the impacted records. It will see if the transaction is success or not. If it is success, it will discard the image. If it is failed, it will reapply the image. So before image is reapplied if the transaction fails. Before images are discarded upon the transaction completion. Everything is transparent. You no need to do anything. It is not in control of the users. It is full control of RDBMS. Okay, this is called as transient journal. For example, here we have the statements: begin transaction, end transaction. What they do? Whatever SQLs embedded in between these two statements are considered as a single transaction, and they will be executed at once. So whenever one SQL is being executed, it will take the before image of rows which are impacted, and then for the second SQL also it is taking the before image. If both the statements are successful, then discard the before images. Otherwise, if we see the fail scenario, the same statements are embedded between begin transaction and end transaction. So first, when it is trying to update the rows in A, it would take a before image, and updating the row B. So before the transaction, before the SQL execution, it will take one more image. Let's suppose this failed. The second SQL failed. Then what it does? It will reapply the before images of all the SQLs, so that the A and B came into the previous status how it was before we actually started the SQLs, and discard the image. This is the way how it would maintain the integrity of the objects even though some of the SQLs are failed in the transactions. By default in Teradata, each and every statement is auto commit. If you don't embed, that means each statement is auto committed. So for each and every statement, it will take the before image, it will observe the transaction success or failure, and it will take a decision whether it has to be reapplied or discarded. But if you group a group of statements in between begin transaction and end transaction, it would be done for all the SQLs, and all the images will be discarded at the end of the transaction only. Once it ensures all the SQLs executed successfully. Okay. So this is the concept of transient journal. So we have one more type of journal called permanent journal, where transient journal we don't have any control. RDBMS will take care of making the integrity of the objects. There is one more journal called permanent journal. As its name indicates, these images which are taken before each transaction, okay, those were stored permanently in the user space. Okay, just a moment, there is a question here. Can we execute rollback and commit explicitly in Teradata? Okay, so as I mentioned, in Teradata, each and every statement is auto commit. So once it is committed, you cannot roll back. So in the Teradata mode, once you execute the SQLs one by one, each SQL is auto commit. So once it is committed, you cannot do rollback. When we can do a rollback? Until the transaction is committed. But here there is no option of rollback because every transaction is auto commit itself. Yeah. But you can set the mode as ANSI in other utilities like BTQ or other utilities, where you can execute in ANSI mode. There you have an option of explicitly commit and explicitly rollback. But generally in Teradata mode, each and every statement is auto committed. Once it is committed, you cannot do rollback, so there is no option of explicit rollback in Teradata mode. But there is an option, you can set your transaction mode as ANSI. Okay, sorry. So you can set your transaction mode as ANSI in other utilities. There you have all these options of rollbacks and commits. But default in Teradata mode, you don't have rollbacks and commits. Okay. So let's see the other journal called permanent journal. As its name indicates, the images which are taken before the transaction are stored permanently in the user space. Okay. So let's suppose I am doing one update statement on a table A. It has taken a before image of the impacted rows and kept it in memory. Even after transaction is success, it won't discard the image. It would permanently store that image. Okay. And I'm doing one more transaction, one more update. It will take the image again and will keep it in permanent space. And again, third transaction, again it will take the before image and keeps the image. So what is the use of it? Okay, it is keep on taking all the images and storing it in the permanent space. Even though the transaction is success, it is not discarding. So what is the use of it? Sometimes if the table is very much important, and even after doing 3 to 4 transactions, if the user realized that the previous 3 transactions are false or wrong, and I wanted my table status how it was before 3 transactions, what we can do, we can request DBAs to get my table status back how it was before 3 transactions. Okay, and to enable this, the permanent journal should be enabled on the table first place. It means when you are creating the table, you have to enable the permanent journal on the table. Okay, what all images you want? Do you want an before image or do you want an after image? You have to set all these options for the creation of the table, because it is all under control of user. Transaction journal, it is not in our control. It is taken care by RDBMS. Even you want, you don't want, you cannot do anything. But permanent journal, if you feel the table is very much important and there may be scenarios where you may request the table status how it was before 2 transactions, 3 transactions, 10 transactions, then you have to set the permanent journal enable for the table at the time of table creation. And then after the some transactions, if you want to have the status back how it was before 3 transactions, you have to request DBA to get the permanent journals applied in such a way that you will get your table status back how it was before 3 transactions. Okay. And in storing the images, we have the options whether you want to store only the before image or after image also, or both the images, before image only or after image only, or both the images. Before image means before actually starting the transaction, it will take the image of the records. After image means after applying the transactions, it will take one more copy of the records. Okay, both the ways. So for every transaction, it may take before image, after image, before image, after image, again before image, after image. Every image or every journal is stored in permanent space. So you can roll back, you can roll forward in case if you want. So all the options are enabled, and as it is very costly operation, you have to analyze is it really required for this table or not, because you understand it is stored in the permanent space of the user, so it is heavy in terms of space and the transactions. Okay, for taking before every transaction, it has to take the images and store, and if you opt for before and after images along with the transaction journal, it would also be taken. So it is a burden in terms of maintenance, in terms of space, So we have to carefully choose whether this permanent journal is really required for this table or not. Okay, generally for what tables we use this? Not for the temporary tables, ETL tables, staging tables. It is only for the model tables, with target model tables where the reports would continuously work on these tables. Okay, for such tables, we use these permanent journals. Okay. So that is the transaction level protection. Okay, so we have seen all the levels of data protection in Teradata. Now let's see the topic spaces and tables. Okay, so let's see what all types of spaces in Teradata. The first type of space is the perm space.